Let's look at part B. Part B is asking us about the coefficient of friction. And here, we kind of glossed over something, but it might have been troubling to you to say that this vertical wall is exerting a force in this direction. Because if this is truly vertical here, when you think of a surface, what can a surface do? A surface can really only exert a normal force that's perpendicular to the surface. That should be perfectly horizontal. Or it can exert a friction force that's parallel to the surface. So as it turns out, when I come back and look at these forces that the rock is exerting, this component of the force that the rock is exerting is equal to the normal force. Because my surface is vertical, so the force that's being exerted perpendicular to that surface is a normal force. And this force that's being exerted parallel to the surface is the static friction force. So static friction is pushing directly up on her feet. Doesn't that kind of make sense? If there was no static friction here and she tried to push like that, her legs would slip down. So, so static friction is the force pushing up and keeping her legs from slipping down. So whenever we're dealing with friction, I know that I need to figure out what the normal force is. So let's just calculate this. I already solved for F rock. We found that on the previous slide. We found that the force that the rock exerts is 273 newtons. Times that by cosine of 15, I find that the normal force is 264 newtons. Okay, so that's the normal force. Now let's figure out how big the force of static friction has to be. So this force of static friction, I've plugged in for the force of the rock, and I find the static friction has to be equal to 70.7 newtons. This is how much force static friction is exerting in order to keep her feet stationary. The question wants to know what's the minimum coefficient of static friction. So, like how slippery can this surface get before static friction is not able to supply this much force. So what I'm going to do is I'm going to consider if this is the maximum force that static friction can supply, based on this normal force, what's that minimum coefficient of static friction? So let's just say this is the maximum force that static friction can supply. Solving this equation will give us the minimum value of the coefficient of static friction. So here I've plugged in for 70.7 is the force of static friction. Here I've plugged in for my normal, and I solved that the minimum coefficient of static friction is this value. Static friction can be bigger than this. It can have a larger coefficient than this. That's fine because the force doesn't always have to exert this much force.